Okay, I had bought this setup here before Christmas. Excuse the mess. So I had to test it out. Unfortunately, the card that goes between the two capacitive plates had dropped out, and it's nearly impossible to get that back in there again. So all I could do was just get it tucked into the bottom plate and just resting up against the top capacitive plate there. So this is actually a pretty cool setup. It shows the electron beam deflection with the magnetic field and electric field. Now one of the problems I have is I only have one major power supply, high voltage power supply. I may try the other one again. I'm not sure if it's going to work or not. Last time it didn't work, so. But then I was having a problem with the heater element. But now I've solved the problem with just a 12-volt battery and a variable resistor here. A lot of times it's better just to go old school and make it work. So I'll just change hands here. I'm not really left-handed, but I should be able to hook up the battery here, and there's the voltage. The filament is only supposed to get 6.3 volts, but where it has quite a load on it, where it's a resistive element, it's, I don't know, whatever, very low ohmage. So I don't know if you can see the glowing there, the element's glowing there now. So unfortunately I'm doing this in the daytime. I wasn't feeling good today, so I took the day off, but my nose seems to be clearing up, so that's kind of weird. I didn't want to bring a sickness into work, which I think I got it from work, but anyhow, so flip on the power supply. It's kind of strange, but you can see electron beam, but it's kind of scattered for some reason. I don't know why. I'll do another video at night so we can see a little better. But I have the ammeter hooked up so I can turn on the power supply and start allowing current. And as you can see, as I give it current to the coils, Holtz coils, I think they're, I'm not sure. I should have been a little bit more prepared. I was just happy to get it going. So the whole idea is the coils can't have no more than 2 amps going to it. I don't know if you can see that. It shows the turns, 320 turns, and 2 amps. So I'm not even close to that. I'm just at 0.6, 0.8, but as you can see, it's deflecting up, which I shown on another video, but I just had a magnet coming in from the side on a Crookes tube. So this is a little more precise, where it has coils that you can, well, it's made for school, that you have a certain amount of voltage going to the electron gun, and for a certain amount of current, say right there, roughly 100 milliamps, you'll see the deflection. Then you give it .200 milliamps, and then you have a little more deflection, and you're supposed to measure. You give it say 300 milliamps, and then it's deflected that much more. So they have sort of a graph, and you plot out for the amount of current you're putting in the coils, how much deflection the electron beam does in the magnetic field. That's sort of the physics project that they would do, and it would be the same with the electrostatic field. They would give it, 2,000 volts, 3,000 volts, and again, it will deflect the same idea. It'll deflect up or down depending on the polarity of the electrostatic field on the plates. But yes, I'm very happy. This came all the way from UK, and it actually still works. That's a big bonus. I didn't know if maybe the filament was broken. The worst that happened was the card fell out, and like I said, I had to jiggle it around because it was inside there, and I was able to jiggle it so it went in between where it's supposed to go. And I have no idea how I could get that back in there, or how it even came out. It must have just been laying flat, and the right amount of bumps or whatever must have popped it out. But I'm happy to say that it does work, and I was able to isolate the filament with the battery is the best way to do it. In a physics lab, they have certain equipment all set up to do this experiment, or demonstration, I guess. And well, I'm just an experimenter. I don't have this specialized equipment. I have what I have. But I hope you find this interesting. The more current, the more deflection, of course. And by reversing the, I turned it off. This ought to be fun. By reversing the polarity of your power supply, as you can see, it goes down. Now, one thing I've noticed, that it seems to me that if you noticed, when it goes up, it's brighter. It seems to be pushing it more towards the card, whereas when it's in the opposite polarity, it almost seems like it's pulling it away. It's deflecting it down, but it's like it's pulling away. And there's another experiment. Well, here comes. There's another experiment that shows it'll excuse me, it'll do a complete circle, and the more magnetic field you give it, it'll actually pull the circle apart so that you'll actually see rings. So that is what I figure is going on here, that the more the magnetic field, it's either pushing it into the card or pulling it away from the card. I hope you like this demonstration. Any questions, post them in the comments. Cheers.